Hi! Welcome to our grade 11 week 1 for HUMMS students. And our objective represents real-life situations using functions including piecewise functions. And now, let's have a brief discussion about functions. I guess you are familiar with functions. It's because functions are widely discussed when you were grade 7, 8, 9, and 10. And because of that, I know you are familiar with this saying, all functions are relations, but not all relations are functions. Okay? And why is that? It's because a function is a relation whose every input corresponds with a single output, and that is why not all relations are functions. And let's have another definition. So a function is an expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, which is the dependent variable. And we all know functions could be represented in many ways. So let's have representations of functions. A function could be represented through ordered pairs. Okay, it could be represented through table, through graph, through what else? Through an equation. And it could be also represented through words. But before we would go through with the representations of functions, let's have first a concept map regarding with functions. Now, the purpose of this one is so that you would not be confused. Okay, as you can see, the words here: independent variable, domain, input, and variable. Regarding with their usage, they are all just the same. Sometimes you would see or you would read on other books, they are using the independent variable of the domain, the input, or the variable x. They are the same. The usage of these words are the same, and the same as with this one. The dependent variable, the range, the output, and the variable y. They are just the same. And do not be confused. Function is equal to f of x. Sometimes you would see f of x or function of x. Sometimes you would see y is equal to. It's because they are just equal. They are just the same. The flow of this one is just like planting trees. Okay, for example, you were planting trees, and then the seeds that you have, the seeds are named independent variable, domain, input, and the variable x. After planting the seeds, it undergoes processes, different processes like the photosynthesis or whatsoever. And after planting these seeds, it would become a tree, and after becoming a tree, then you would have the fruits now. And the fruits that you have are called the dependent variable, the range, the output, and the variable y. So meaning you just reap what you sow. All of those here are the result of what we have on this circle here. Okay, now let us continue with our representations of functions. And now let's have an example on the set of ordered pairs. Now, how would we identify if the set of ordered pairs we have is a function or not? Now, as you can see, you would focus on the domain. Okay, if our domain has no repetition, so let's use our example number 1, has no repetition, then it is a function. Our example number 1, our domain has no repetition, then therefore our example number 1 is a function. Now, on our example number 2, it is not a function. It's because on our domain there is a repetition, then therefore it is not a function and just a mere relation. Okay, so let me repeat it to you. If we are looking into the set of ordered pairs, whether they are function or not, you would look into the domain or the x. Okay, now if there is a repetition, then it is not a function, but if there is none, then it is a function. So let's go to table. On table, it's just almost the same with our set of ordered pairs, wherein we would just simply look into our domain x or our independent variable. Now let's have this example. So let's have the example number 1. As you can see, our example number 1, this is a function. It's because, let's look into our domain. Our domain has no repetition, then therefore it is a function. Now, for example, what if we have a repetition on y or in our range? It's still okay. Even if, for example, this is 5 and this is another 5, it would be okay because we would just simply look into our domain. Now, if there is a repetition in our input, our domain, or our x, then therefore it is not a function. But since on our example number 1, it has no repetition, then therefore it is a function. Now, let's look into our example number 2. Our example number 2 is not a function simply because, as you can see, there is a repetition on our x. So, since there is a repetition, then therefore it is not a function. Now, identifying function or not on ordered pairs and table are just the same. Now, let us proceed to our graph. Now, in our graph, in order for us to identify whether it is a function or not, we would use what we call the vertical line test. Okay, wherein on a vertical line test, we would simply draw a line on our graph. And then upon drawing, if that line hits our graph more than once, then it is not a function. Now, let's have an example. Okay, these graphs, we have two graphs. Now, for example, on the first example, let's do the vertical line test wherein we would draw a vertical line. So, let's draw a vertical line and that's it. And upon drawing the vertical line, we figured that it hits our graph more than once. Then therefore, our graph number 1 is not a function. Okay, it is not a function. It's because upon doing the vertical line test, it hits our graph more than once. Now, let's have the other example. Let's do a vertical line test here. And okay, as you can see, the vertical line hits our graph only once. And then therefore, since it hits the graph only once, then it is a function. As easy as that. If our vertical line hits our graph more than once, then it is not a function. But if hits our graph only once, then it is a function. And on equations using the variables x and y, so I could say that it is a function if and only if the exponent of y is equal to 1. But if the exponent of y would be greater than 1, let's say 2, 3, 4, and so on, then it would not become a function regardless of the exponent of x. Okay? So let's have an example. Okay? Now, for example, let's have our equation number 1. Y squared is equal to, rather than y is equal to x squared plus 1. Now, as you can see, this equation, let's have it as a graph. Let's have it as a graph, and that is his graph. Now, if you could remember on testing the graph whether it is a function or not using the vertical line test, now if we would draw a vertical line here or everywhere, it would only hit our graph once. Then therefore, it is a function. Look at this one. This is a function because the exponent of y is equal to 1 and the x is having a square. It doesn't matter. This is a function. Now, let's have another example. Our equation number 2. Our equation number 2 is y squared is equal to x plus 1. As you could observe, our y here is raised to the second power. Then, therefore, this is not a function. Why? Let's look at the graph. As you could see, this is a parabola. Then, if we would draw a vertical line here, then it hits our graph twice. It hits our graph twice, then therefore, this is not a function. Now, again, let me repeat it to you. If the exponent of y would be greater than 1, then therefore, it is not a function. Now, let's have our equation number 3. Equation number 3, y is equal to x cubed plus 3x squared plus 2x plus 5. Our equation number 3 is, okay, is this one. Okay. Now, this is the graph of our equation number 3, and this is a function. It's because if we would draw a vertical line anywhere, then it would only hit our graph once, then therefore, it is a function. Okay? Our graph number 3, or rather than our equation number 3, is a function. I guess that's all for the equation, and I would just want to endorse this online graphing calculator to you. It's desmos.com. It's very handy, especially for the students who have problems on graphing. This could be used in many ways. Okay, this could be used in many ways with different functions. So I would recommend this if you do not have your calculator with you, your graphing calculator with you. Since you have the internet, you may use this one, desmos.com. And now let us continue and let's look into our objective. Then again, represents real-life situations using functions, including piecewise functions. And now let me give you a real-life situation that most of you may relate. Okay, now so let's have a worded problem that would be a real-life situation using functions. Okay, let's have this one. Okay, now our worded problem, let's read it. Jasril is a hard-working student in Singao Integrated School. In this season, his part-time job is selling rambutan. As a middleman, he earns 5 pesos in every kilo being sold. Okay, now this is an example of a real-life situation wherein function is being applied. Now let's have our questions. Question number 1, how much will Jasril earn if he sold 10 kilos of rambutan? Question number 2, how much will Jasril earn if he sold 50 kilos of rambutan? Okay, now in order for us to answer these questions, we may use what we call the table of values. Okay, so we let K for the kilos that are being sold, and the F of E is for his earnings. Okay, so look into our table of values. K here is our input. This is our domain and as well as our independent variable. And E here, the F of E, is our output, our range, and our dependent variable. Now let's fill in our table of values. As we all know, based on our worded problem, as a middleman, he earns 5 pesos in every kilo being sold. So meaning, if Jasril is able to sold 1 kilo, he will earn 5 pesos. Okay? And then let's continue. Then how about in every 2 kilos? 3, 4, 5, 6, 7, let's say 8, 9, and let's have 10. Okay, in 10 kilos, let's see what would be Jasril's earning. Okay, so for example, in every kilo he sold, he earns 5 pesos. So therefore, if he will sell 2 kilos of rambutan, he will earn 10 pesos. Okay, so and then for 3 kilos that would be 15 pesos. For 4 kilos that would be 20, 25, 25, 26, 26, 25, 30, 35, we say 40. Okay, let's do it this way. So in every kilo, he earns 5 pesos. Then he would earn 10, 15, 20, 30, other 25, 30, 35, 40, 45, 50. Okay. Based on our table of values, we could see that in every kilo that Jasril sold, he earns 5 pesos. So from the first kilo he sold, he earned 5 pesos. For 2 kilos, he earns 10 pesos. And for the 10 kilos being sold, he earned 50 pesos. Okay, he earns 50 pesos. So now, let's answer the first question. How much will just earn if he sold 10 kilos of rambutan. So how much would it be? It would be what? It would be 50 pesos. Okay? So Jisrael will earn 50 pesos if he was able to sell for at least 10 kilos. So 10 kilos of rambutan is equivalent to 50 pesos as he's earning on his part-time job. Now, let's proceed to the second question. How much will Jisrael earn if he sold 50 kilos of rambutan? Okay, now, so it would be quite impractical if we would do, and if we would continue our table of values up to 50 kilos. Like, for example, you would say, for 11 kilos, he would earn 55. For 12 kilos, he would earn 60. For 13 kilos, he would earn 65, and so on, up to 50 kilos. So, it would be quite impractical, and that is why we need to identify our function, okay? We need to identify our function based on the table that we have, okay? So we need to formulate our function based on the table, specifically based on the pattern that we are seeing in our table, okay? So meaning, let's make the function, let's formulate the function. So our f of e, okay, f of e would be equal to, now, as we know, in every kilo he earned it's 5 pesos, right? So the relationship between his earning and the kilo is that he earns 5 pesos in every kilo that is being sold. So therefore, we could say that constant here is 5. The constant here is 5. It's because on every kilo being sold, he earns 5 pesos. So therefore, we could say 5. As for the constant, having the relationship of in every kilo, he earns 5 pesos. And then we would have 5K. Why 5K? K here, let's change the color. K here refers to the kilo, the number of kilos being sold. Okay? This K here refers to the number of kilos being sold, and K here is our independent variable. F of E, or his total earnings, is our dependent variable. 5 now is the constant in our function, wherein 5 has its relationship regarding with the earnings and per kilo. So in every kilo he sold, he earns 5 pesos. So therefore, this is now our function. F of E is equal to 5K. This is now our function based on our table. And now let us answer the question, how much will Jisrael earn if he sold 50 kilos of rambutan? So let's use the function 5K, and let's substitute. K refers to the number of kilos, right? And second question is asking about 50 kilos of rambutan. So let's have it 50. Like that. And then let's do the multiplication. Is equal to 5 times 50. So if Jisrael is able to sell 50 kilos of rambutan, he will earn how much? 5 times 50, that's 25. And that would be equal to 250. And that's it for our function. So by using the function, we were able to solve how much will Jisrael earn if he sold 50 kilos. And definitely we could answer how much will Jisrael earn if he sold 100 kilos. For example, he was able to sold 100 kilos, and that would be 5 times 100, and he will earn 500 pesos. And in this season, I guess he could sell that 100 kilos. It's because it is the season of fruits right now. And now, let's continue to our next example. And our next example would be an example of a piecewise function. And before we would proceed to our example, let us first define a piecewise function. A piecewise function is one which is defined not by a single equation but by two or more. So therefore, you could say piecewise function is more like a function, but of course, it has more than one equation. Okay, so we use piecewise function to describe situations where a rule or relationship changes as the input value crosses certain boundaries. So there are certain boundaries wherein if the input value would cross these certain boundaries, therefore the value would change. Let's have an example of piecewise function so that you would understand it better. Now, this is our example for our worded problem involving piecewise function. Before we would read this one, let me tell you this first. Reading comprehension is the key in order for us to answer different kinds of worded problem. So therefore, I would suggest if you would not understand our worded problem in a single reading, you may read it many times, okay? Read it many times so that you will understand what is the worded problem all about. Now, let us read our worded problem. Rayan is a wholesaler of durian in Kidapawan City. The price of her product depends on the number of kilos being sold. For 50 kilos and below, the price of durian is at 20 pesos per kilo. And for above 50 kilos, the price is at 15 pesos per kilo. Okay, that is our worded problem. As you could see, as I have mentioned earlier, when we say piecewise function, there is a certain condition or boundaries that our values would change. Let's focus on this one, in these sentences. For 50 kilos and below, the price of durian is at 20 pesos per kilo. And for above 50 kilos, the price is at 15 pesos per kilo. So as you can see, there is this is the boundaries that we have, the condition that we have, and that is why the value would change from 20 pesos to 15 pesos. It is very important for us to be vigilant on these conditions or boundaries so that we would know what we would do. Now, let us continue. And let's have the representations first before we would have the function. So let K equals the number of kilos being sold, and F of P equals the total price of durian being sold. Now these are our representations, so we would use K for our independent variable, meaning the number of kilos being sold, and F of P is the total price. Since this is the total price, then this is our dependent variable. So now, let's have our function. As you can see, we would have two functions in this case because of this boundary. 50 kilos below, the price of durian is at 20 pesos per kilo, and for above 50 kilos, the price is at 15 pesos per kilo. So therefore, we could say that the F of P is equal to, we would have two functions. Okay, so let's have this one, this side. So the F of P would have two functions, and let me have this for a while. This will be 72. Okay, this one. I don't know how to make a big one, but we just did a big one. Okay, now, in order for us to identify the functions, we could just do like what we did earlier. We could do the table of values in order for us to get the function. We could have this table of value, then again, and then in order for us to formulate a function, or we could just have it by understanding our worded problem. Now, as you can see, we will sell the durian on the worded problem. The durian is at 20 pesos per kilo for 50 kilos and below. So therefore, the constant on the first function, on the first equation that we would have is that 20 pesos would be the price of the durian per kilo, right? 20 pesos would be the price per kilo. If, okay, there is a restriction now, if the durian that are being sold are 50 kilos and below. So therefore, 20 pesos per kilo is only applicable 20 pesos per kilo is only applicable if the number of durian is at 50 and below. So therefore, we would write the restriction K is less than or equal to 50. Take note, less than or equal to, we have this equal to because 50 is included. It is included on the function. Now, let's have the other function. As you could see, let's focus on this statement. For above 50 kilos, the price is at 15 pesos per kilo. So now, the price went lesser if you would buy more kilos of durian. So therefore, the constant 20 now would change into 15. It would change into 15 depending on the number of kilos if, okay, let's have the restriction, if the number of kilos is greater than 50. So meaning, if you would buy from Rayan, you would buy a durian, a set of durian from Rayan, having, let's say, you would buy 51 kilos of durian, then it would only cost 15 pesos per kilo. And this is now, or these are our functions. These are our functions. The f of p is equal to 20k if k is less than or equal to 50, and the f of p is equal to 15k if k is greater than 0. And we can use and utilize these functions in order for us to answer different questions like, how much will I pay if I will buy 10 kilos of durian? So if you will buy just 10 kilos of durian, then you would use this one. If the number of kilos is less than 50, the price is 20 pesos per kilo. Therefore, if you would buy 10 kilos, that would be 20 times 10, and then you would pay 200 pesos. And for the next question, how much will I pay if I will buy 60 kilos of durian? So 60 kilos, it's greater than 50. So therefore, the price would be 15 pesos. So that would be 15 times 60. Then you would pay 900 pesos. And if there are further questions, we could use this function to answer those questions. And this is an example of a piecewise function. And I hope I was able to help you, grade 11 students. And if you have further questions, you may comment down below on our YouTube, and I would definitely answer those questions. And or you could comment on our page, on our Facebook page. Okay, so by the way, if you are just a last message. By the way, if you are asking, is it possible for a durian to be 20 pesos per kilo or to be 15 pesos per kilo? I would say yes, it is possible. It is legit. Okay, I guess last year or last year, I was able to buy 20 pesos per kilo at Singao. Okay, so if you wanted to find durian and you wanted to find durian in a very affordable price during the season of fruit in Kidapawan City, it could be as less as 15 pesos per kilo in Barangay Singao. So it's very affordable. I guess that I think it was way back 2016. If I could remember, 2016, I was able to buy 15 pesos, not per kilo. Okay, it's not per no, it was 25 pesos, but not per kilo. It was 25 pesos per container, and there were really many plastic containers. I guess it's very affordable at Barangay Singao, especially on the season of fruits. And I guess right now the season of fruits is starting, and for those who could watch my video and not from Kidapawan City, this time you may visit Kidapawan City because the season of fruits is coming and there's a lot of fruits in our city. And I guess that would be all. Thank you so much for watching my video, and I hope I was able to help you. Thank you.